Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 4 of Observability Zero to Hero series. Till now, we have completed 3 episodes in this series where we started with what is observability. We learned about metrics, monitoring, Prometheus, Grafana, and many other interesting things. In today's video, we will learn about instrumentation of custom metrics. We will learn what is instrumentation, why is it very important. Then we will see practically how metrics are instrumented using a Node.js application. And then we will learn about the alert manager configuration and how to fire alerts in real time using alert manager. This video is going to be very practical and informative. Make sure you watch it till the end. After watching the video, if you want to get the notes, you can go to the GitHub repository. Link is in the description and just go to the Day-4 folder. You can even find the source code of the application that I'm going to use in this series, in this particular video. And you can also get the README file where you can see the complete details that I'm explaining in the video. You can use it as revision material. Architecture diagrams are also provided. Okay, so let's start with what exactly is instrumentation. If you have followed this series, in the very first episode of this series, when I was introducing you all to observability or explaining what is observability, I mentioned observability is a collective responsibility. What does that mean? Let's say you have a very good DevOps or SRE team and they have built a robust observability stack. Let's say they have set up Prometheus for monitoring, they have set up Grafana for advanced dashboards, they have set up EFK stack for log aggregation, and they have set up Jaeger for dynamic tracing. Everything is set up and running, ready to use. But what if the applications in your organization, let's say you work for a e-commerce application where you have different types of services, if these applications are not omitting the metrics, or if logging is not done in these applications, or traces are not provided in the application. So if developers of this application are not giving you this information or giving the observability stack this information, what is the point? It doesn't matter if you have Prometheus, if you have Negios, or if you have anything, if the instrumentation of metrics. So this process of writing the metrics in the application or writing the logs in the application or defining the traces in the application is called as instrumentation. And this is very important because otherwise the setup that you have done or the complete stack that you have set up is of no use. Of course, you might say, but Abhishek, I can use some exporters, right? But exporters cannot get the information that is very specific to your application. For example, I want to see how many users have logged in to my application in the last 30 days, or how many of them have created an account in the last 30 days, or something like the latency specification, a specific latency specification of your application, or the HTTP request duration of a particular service. Exporters cannot get you accurate information about these things because exporters are plugins. They are set to do a particular activity. For example, if you take a node exporter, it can get the information such as CPU or memory or the disk utilization of your Kubernetes nodes. Or let's say you have a MySQL exporter. It can get information from the database or metrics related to your database. But if you want to identify the traces, or if you want to put your application in the debug mode and get additional information about your application or metrics related to your application, instrumentation plays the key role. Now it's up to your organization if this instrumentation is taken care by developers, platform engineers, SRE engineers. It depends from organization to organization. So if you assume that in your organization, instrumentation is taken care by developers, so it is their responsibility to provide all of this information, and it is the responsibility of DevOps and SRE engineers to set up all of these things and create dashboards, whatever is required, fire the alerts, all of them. Now, Abhishek, can we see an example like how developers instrument these metrics? For sure, we have a very good application. We are going to deploy it. We are also going to see it through the Prometheus UI. But before that, there is one simple concept that you need to understand. You don't have to master it if you are not instrumenting the metrics in your organization. Most of the times, DevOps engineers does not do that. But it is important to understand, just like how every programming language has data types. If you're using Python or even shell scripting to represent the data, you have different kinds of data types, right? You have strings, you have list, you have dictionary. Why do you have different types of data? Because not every data can be represented in a specific data type. Sometimes you need a string to represent, sometimes you need a list to represent the data, sometimes you need a dictionary to represent the data. Similarly, even when you look at metrics, there are metric types. Why? Because not every metric can be represented in the same metric type, just like your data types. So you have four popular metrics types, especially if you are using Prometheus. So the developers of the application can instrument the metrics using this four different metrics types. The first one is counter. Second one is gauge. Third one is histogram. And fourth one is summary. So, like I told you, if you are a developer or if you're doing the instrumentation, you need to know them in detail. Otherwise, you just need to understand what is the responsibility of each of them. Like, when do you need to use this data type? When do you need to use this? When do you need to use this and this? Let's understand that. So, when you have a metric that is always incrementing, that is, the count of this matrix is always going high. For example, the logins in your application, if you want to see the number of logins or accounts created with the application in the last 30 days or over a particular period of time, this is always an incrementing number. Because if once the user has created an account, the account is created. You are tracking only the account created metrics. You are not tracking if the accounts are deactivated, if they have deleted the accounts. No, that is not the purpose. In the metrics, you are only seeing how many accounts are created. And that can never go down, right? So today, if it is one, it can either be one, or tomorrow it can be two, three, four, five, keeps on increasing. So such kind of metrics which are always increasing is called as the counter metrics or that has to be represented in the counter metric type. Another example can be the number of HTTP requests received by your application. If the HTTP request is received, it is received, right? So that is always again an incrementing number. Now you have gauge. This can be incrementing as well as decrementing. So when you have a graph like this, unlike a counter, right? So this particular thing or this particular metrics which are incrementing and can be decremented as well should be represented in the gauge metric type. Abhishek, can you give some examples? Sure. Let's say you want to see the number of config maps or CPU utilization or memory utilization. These things can go up and come down. Maybe at 11 o'clock, the CPU utilization was 67. I'm just giving an example, 67%. And 11:15, it might be less, 50%. 11:20, it might be more. Again, it can be down. So when you have such information that you want to represent in the metrics, then the developers should record that information in the gauge metric type. If you are new to programming, you might find it difficult, but if you are already doing programming with any programming language or have the basic, I think this is very simple to understand. You need to know the nature of the metric. If the nature of the metric is always incrementing, go with the counter. If the nature of the metric is incrementing as well as decrementing, go with the gauge. Or if you're not worried about incrementing and decrementing, but if you need some bucket of information, then you should go with histogram. Abhishek, what is this bucket? I'll make it very simple. Let's say your manager asked you, what is the HTTP latency? Or you want to see that how many times the CPU utilization went below 50%. These kind of things should be recorded in the buckets. So if somebody is asking you, what is the HTTP request duration? Okay, let's take this as an example. Instead of taking too many, HTTP request duration. I'm not talking about the HTTP request number. I'm talking about HTTP request duration. If somebody is asking you, tell me how many times the HTTP request took less than 5 milliseconds, or how many times HTTP requests have taken more than 100 milliseconds. If you are using counter or gauge, how can you give this information? It's not possible, right? So that's why you create buckets and you will say this bucket is for 5 milliseconds. This bucket is for 10 milliseconds. This bucket is for 100 milliseconds. And at 11 o'clock, let's assume your application got a HTTP request. And if it is taking 5 milliseconds, you will put that request in this bucket. Again, maybe at 3 o'clock, you got another request that took 5 milliseconds or less. Again, you will put this in bucket. So this way, you will record the information in buckets. 10 milliseconds, it will go to this bucket. 100 milliseconds, it will go to this bucket. And now when somebody asks you, give the information of 5 milliseconds, you will give this bucket back to them, or this bucket back to them, this bucket back to them, right? This is how you make use of buckets so that you can track information about duration or latency, these kind of things. Now, summary is exactly same as histogram, but at this point, I will not go into the details of summary because it might confuse the beginners. If you want that, it is available in the documentation. And also, I will cover summary as we progress in the series. We have a dedicated video for instrumentation that is using OpenTelemetry. During that time, I will talk about summary. Now we are talking about instrumentation of metrics using Prometheus. So this particular knowledge or this particular basics is good enough. Now, Abhishek, can we see an example like you have mentioned? a demo application? For sure, let's go to the GitHub repository, click on the dot so that we get a Visual Studio interface. Go to the Day-4 and let's go to the application section. Click on the service A. You don't need to understand this application. It's a very simple application which returns, which has multiple APIs. I'm going to show you that. So if you go to the index.js, okay, so there is service A that is talking to service B for creating a simple API, but our focus is metrics. If you go to index.js, I have taken a Node.js application, and here you can see how metrics are instrumented. First you need to do is use something called as Prometheus client, or if you don't want to use Prometheus specifically, Abhishek, I want to use something which is a standard, like tomorrow I might use something else. Tomorrow from Prometheus, I want to move somewhere else. You can also do something called as open telemetry. We will get there. For now, you need to instantiate a Prometheus client, and using this Prometheus client, you will declare the metric types. For example, here we have defined the first metric type where using the prom-client, we are saying, okay, I want to define a counter. So the metric type is counter, a new metric type. What is that name of that metric type? Counter. But what is the name of the metric? It is HTTP request total. Can HTTP request total can ever go down? Definitely not. If a HTTP request is received, it is received. So the count cannot go down. That's why HTTP request total is always an incrementing number. That's why the developer will record this in a metric type called as counter. Okay. So some description is also provided. What does it mean and all. And for us to query this specific metric type of this specific application, you need labels, right? So we were using labels from Prometheus UI, and that labels are also defined in the definition. Then another example, like I said, the HTTP request duration seconds, right? The same example that we have taken here, HTTP request duration, it has to be done in buckets. That's why the developer will define a metric type called as histogram, and see the different types of buckets that are created. So this is important. One bucket for 0.5 milliseconds, okay, seconds, one bucket for 0.5 seconds, 1 second, 5 seconds, and 10 seconds. So you have different buckets. If somebody is asking you about 10 seconds bucket, give this information or give this bucket. So buckets are created for metrics of types like HTTP request duration. Initially, you might be confused like, okay, this should go to histogram, or this should go to summary, or this should go to counter. But as you keep writing the metrics, like I write a lot of metrics for the application, the metric server. So probably it is easy for me. But for beginners, you will take some time understanding like what type of metric type that I have to use. You will also face this problem if you are new to programming. Should I go to list or should I go to a dictionary type, right? As you keep writing the programs, you understand. Similarly, as you keep writing metrics, you will understand about it. Okay. Once different metrics types are defined, then it's about the logic in the application. Like when you want to track a particular metric, and this code is very specific, right? This is very specific to Node.js. If you have some knowledge of Node.js, you can understand when and how the metric is being incremented. Okay. So like I said, we have different APIs also on this application. Once we deploy, we use these APIs to trigger some actions on the application. So for that, we first need Prometheus. So I have created this Kubernetes cluster. So the cluster is already there. Now I will install Prometheus stack on this cluster. So let's run this command, the Helm chat. So in the monitoring namespace, okay, it says the chat is still in use. So let's remove the Helm chat. Okay, so I have uninstalled the release. Let me try again. So the installation of Helm stack. So we are using the Prometheus stack here because we can get Prometheus, we can get Grafana, we can get Alertmanager. Abhishek, where can I get this command from? If you have followed the series, you already know it. Otherwise, go to the Day-2 folder, and within the Day-2 folder, you can find the complete steps, how to download Helm, how to create this stack, how to use them. Everything is provided, even how to expose the Prometheus UI as well. So let's copy the Prometheus UI command, the port forwarding. Once this is done, the Prometheus stack is installed. We will expose the Prometheus server. And what we will do is, first, we will try to see the custom metrics by deploying the application, right? So the application that I showed you, the Node.js application, we will deploy it on the cluster, and we will see if the logic that we have written here, the custom metrics related to the HTTP request duration or related to the counter metrics that we have created, total HTTP requests, can we see that on Prometheus or not? For service A. So the name of the service is service A, right? So can I see that for service A or not? We will start from that point. And then we will see the graphs, how they are of counter type, how they are of histogram type, all that. Finally, we will cover the alert manager configuration. So now let's expose the Prometheus using the kubectl port forward command. Cool. Let's verify if Prometheus is exposed. Okay, great. So we have Prometheus exposed. All the steps are in Day-2 of the GitHub repository. So let's deploy our application now. So let's go back to the Day-4 folder, and we have something called as Kubernetes manifest repository, where the deployment of the services, the deployment file is provided, service is provided, but we would be deploying that using customize. So if you go to the README file, we have this. So the Docker builds I have already done, and if you want to use my image, you can use these images. So just go to the Day-4 folder and create a namespace called dev kubectl. I've created the dev namespace, and using customize, let's just apply those manifests. So the deployment is created, service is also created. Let's verify if the pods are running. Kubectl get pods and dev. So this is our Node.js application. Service A is already running. So we need to wait for both of them to run. Perfect. So service A will talk to service B. It's just a simple microservice architecture application. And if you look at kubectl get svc in the dev namespace, so service A is exposed with load balancer service type because I'm going to access this service through the user interface. Communication between service A and service B is internal. So as you know, it will take time for the load balancer service to come up. Okay, now the application is running. As I said, it's a very simple application. When you access the application, it shows the health check as running, and it also supports different APIs. So it supports slash healthy, server error, not found, logs. For example, if I just do slash logs here, so you can see a simple log that it is generating. Now our goal is to go to Prometheus, right? And try to see the custom health checks that we have instrumented in the application. Is Prometheus reading it, right? This is another important point. Can Prometheus read directly if you have instrumented the custom metrics? Let us see. So one of the metrics that we have instrumented, if you go to the application, index.js, and let's see this metric that we have instrumented, HTTP request total. Let's run it, execute. Okay, it returns nothing. Why? So this is the important point. Why Prometheus is not returning any metrics of the custom metrics that we have written. Abhishek, now the instrumentation is also done. Why is Prometheus not giving me? Because there is something called as service discovery, right? So what you have done is you have instrumented metrics, you have created the Prometheus stack, but this application on your Kubernetes cluster, there can be multiple applications, right? How does Prometheus know that from which applications does it have to fetch the custom metrics from? If it is a node exporter, it knows it has to get from the nodes. If it is a DB exporter, it knows from which database it has to get. Similarly, if Prometheus needs to know out of 100 applications on your cluster, from which application should it has to fetch from slash metrics endpoint. What is this slash metrics endpoint? Again, in the application, if you go here and type slash metrics, so see, these are the metrics our application is omitting. On the metrics endpoint, our application is providing the metrics in the format that Prometheus can understand. But Prometheus is still not reading it. Why? Because you did not tell Prometheus that, okay, so you need to identify this application. For that, there is something called as service discovery. So how service discovery is done? Very simple. You just need to deploy a custom resource or a YAML file, and that YAML file will take care of the service discovery, right? So we have that steps also provided here. So just run this command, kubectl. This is the service monitor manifest. So all that I have to do is just run this command. I'll also show you the configuration. Don't worry. So we have this Alertmanager service monitor manifest repository. Sorry, the folder, this one. And here you have Alertmanager configuration and service monitor configuration. I will come back to Alertmanager configuration in just 5 minutes. But right now, let's look at the service monitor configuration. So it says in the dev namespace, okay, match the service called as service A and get the metrics on it on the slash metrics endpoint. That's it. So this will be read by your Prometheus and it will fetch the metrics that your application is providing on the slash metrics endpoint. All these metrics. So let's try to do that. Go here, run the command. Of course, Alertmanager will fail at this point of time because I haven't configured it completely. But our purpose is the service monitor. We will get back to Alertmanager. Cool. Now I have created service monitor. Let us see the same command that we have fired. Okay. I will execute again. Let's refresh. So it just took, I think, less than 2 minutes for the service monitor to reflect the configuration. No additional changes are done. I just changed this to 1 minute, the time, and I can see the graph. Like if you increase this, maybe 30 minutes, you see the graph, very less graph because the application is just deployed. So just change it to, let's say, 1 minute. and you got the information about HTTP requests total. This metric was not seen before. Right now, why you are seeing it? One is you have instrumented. Second, you have created service monitor. So this is the process that you even need to probably explain in the interview or set up in your organization. Step one is instrument the metrics. If you are dealing with applications, custom metrics, step one is instrument. Step two is set up Prometheus or your complete monitoring. And step three is service discovery. So you need to tell Prometheus that, okay, these are the services that you need to identify. Using these things, the complete metrics are set up. Now, Abhishek, can I fire some alerts? Okay, you have covered the monitoring part. Now, we have also set up the alert manager using Prometheus stack. So, how should I fire some alerts? So, for that, what you need to do is to fire the alerts. Just you need to create a alert manager configuration file, just like how we have created the service monitor, right? So, in the alert manager configuration file, you have to provide which alerts do you want to configure. For example, here in the alert manager configuration, I am saying that I need the alerts for high CPU usage and pod restarts, that is container crashes. So we will crash our container intentionally and we will see if the alerts are fired or not. And who is the receiver? Where do we want to send the alerts? So we will use our email, right? We will see if the alerts are fired to our email or not. So I will provide the receiver information as send mail, where just provide your email ID in the places that is provided. You will also need a password, because if somebody has to send you an email, SMTP server, it will expect the password. For that, first you need to configure the password. For Gmail, steps are very simple. Just go to your Google account, right? Go to your Gmail and click on manage Google account. You will reach to this page. Just search for app passwords. Okay. So just provide again your uh, username and password. So it will ask for app passwords. If you don't have two-factor authentication, you might not see this. So enable two-factor authentication on your email. In the app password, let's provide the name as Alert Manager, create, and this is the password that we got. Now we will take that username, we will take this password, and we will go back to our Alert Manager configuration. So in the Day-4 folder, right, go to this particular thing, perfect, and go to the email secrets.yaml. Everything is provided, and what you need to do is take this password, right? Take this one, convert this to base64, echo. Let's put this in the double quote, base64, and this is the one that we got. Now go back to the email secrets file, copy this, remove, and paste. Great. So this is done. Then what is the next step that is left to be done? If you go to the README file, you can see the steps very clearly. First, review the Alert Manager configuration, right? We have seen that. Then it says go to the email secrets. And last thing, go to the Alert Manager configuration file and update your email address. So Alert Manager configuration, and in places where you need to provide the email address, just provide the email ID, which I have done. So this is a dummy email account. No problem if I get the alerts there. So I have created one dummy email account and I have provided that. Save the file. Perfect. Now again, run the customize. because we have updated our configuration files. So I will do kubectl apply minus k dot. Okay, so the secret got configured. Perfect. Now, what I am going to do is I will verify if the alert manager is configured correctly or not. For that, what I'm going to do is I will go to my application and use the endpoint called crash. So this will crash my application. The program is written in such a way that when you do slash crash, the application will be crashed. You can also see that if you do kubectl get pods hyphen n dev. See, the pod has crashed one. And if you see after another 20 seconds, you will see the pod will crash again. Or we can just do one more time crash slash crash. Yeah. So it is taking time. Just make sure. Perfect. It is crashed twice. Now, as soon as it is crashed, you can see here on my mobile, I have got the notification. Let me show you. Immediately, Alert Manager has notified me that, hey, your application has crashed. See, the pod restart, the pod restart notification is sent to my mobile because I have my Gmail configured on my mobile. So this is how Alert Manager can send you the alerts where you can configure on the pod crash, on XYZ things, whatever you would like to configure, right? So make sure you follow the notes properly because the steps are provided each and every step. You can learn the instrumentation as well as firing custom alerts. Thank you so much for watching today's video. I hope you will find it useful. Take care, everyone. See you all in the next video. Bye bye.